Good afternoon. Welcome to week 6 of the NPTEL course on calculus for economics, commerce and management. So this week we were introduced the concept of differentiation and differentiability. So the questions are also based on those concepts. We will wait for just about a minute or two for some other students to join, and then we will begin with the session. Okay, so let's get started. The first question, it's a true false type question. State whether true or false the function fx equals mod x is differentiable at x equals 0. True or false? So I will launch the true false type poll for all of you, and please select the correct option in the poll. Sorry. Okay, let us now discuss the answer. For that, let me draw the graph of fx equals mod x. My x-axis and my y-axis. And the graph. So this is how the graph for fx equals mod x looks like. This is mod x, this is the x-axis, this is the y-axis or fx, and the definition for fx equals mod x is given in a piecewise form as follows. So fx equals mod x is defined as follows. It is positive x for x greater than equal to 0 and negative x for x less than 0. Now we need to look at this point x equals 0. So from this fx, if we write down the derivative, we see that it will be plus 1 for x greater than equal to 0 and negative 1 for x less than 0. And we clearly see from here that the right hand derivative is not equal to the left hand derivative. And what are these right and left derivatives? So right derivative is means positive x values coming from the right side of x equals 0. So this is the right derivative, x greater than equal to 0. And the left derivative is approaching x equals 0 from the left side. That means negative x values. So this is the left derivative. And these two values are not equal, and because they are not equal, so the function is not differentiable at x equals to 0. So this statement is false because the function mod x is not differentiable at x equals to 0. It is differentiable everywhere else. So just at x equals to 0 it is not differentiable, but at x equals to 1, x equals to 10, x equals to minus 5, at all other places other than x equal to 0 it is differentiable. And the value of derivative is given over here. So if it is positive x values, the derivative is plus 1. For negative x values, the derivative is negative 1. Okay, so I hope this is clear. If you have any question, feel free to either ask in the Zoom chat box, or you can simply unmute yourself and ask right away. Okay, so moving on to the next question, question number 2. Again, this is a true-false type question. Define the function f from 0 to pi to the set of real numbers as fx equals tan x for all x which is not equal to pi by 2. And just at pi by 2, we define the value f pi by 2 equals 0. State whether true or false that f is differentiable. Once again, it's a true false type question, so I will relaunch the true false type poll. Take a few minutes to think about this and answer in the poll. Some people answer in the Zoom chat box. I would not recommend that. It is best if you answer in the Zoom poll itself. Okay, now we will discuss the solution. Once again, let us begin by making the graph for the function. So that's my x-axis. Okay, so that's how the function will look like, and it will repeat because it's periodic. Tan x is periodic in pi. So this is 0, this is pi by 2, and this is pi. And the function is periodic in pi, so after pi it will repeat. And this is the function tan x. Now at x equals to pi by 2, we are defining the function such that f pi by 2 equals 0. So this function just at pi by 2, the value is 0. Now clearly, even looking at the function, you can say it is not differentiable. Why? Because it is not continuous itself. There is a continuity break in this function. Because it is not continuous, so it is not going to be differentiable. So f is differentiable is a false statement. Earlier this function mod x was a continuous function, but even though it was a continuous function, it was not differentiable because the left hand and right hand derivatives were not equal. Now here the function is not continuous itself. So if it is not even continuous, then it will definitely not be differentiable. And we can look at it. So if we look at it, so fx is equal to tan x, and f prime x equals sec square x, which is 1 over cos square x. And this function is not defined at x equals pi by 2. Because cos pi by 2 is 0. But here we have defined the function slightly differently. So one way of saying is that this is not continuous. That's why it is not differentiable. And other way we can actually see is that, and so this f prime x, if we look at it, so it is sec squared x. And now from the trigonometric identities, we know that 1 plus tan squared x is sec squared x. Now just at x equals 0, f prime x will be 1 plus, sorry, not at x equal to 0, at x equals pi by 2. And this is not, so this derivative is not defined at x equals pi by 2, and in addition all odd multiples of pi by 2. It's not defined at all odd multiples of pi by 2. Now for right hand derivative, if we look at pi by 2 plus, and the other derivative will be x equals pi by 2 negative, the left hand derivative. And both these derivatives tend to infinity. So although right hand and left hand derivative both tend to infinity, but the value at the x equal to pi by 2 value, the derivative is 1, and it is not defined for other odd multiples of pi by 2. So this function is not differentiable. Moving on to the next question. This time it's a multiple choice type question. Let fx equals x squared plus 1 and gx equals x squared minus 3x plus 2. Then the function square root f over g is well defined and differentiable on which of the following range we need to see: r or r minus 1 comma 2, r minus the interval 2 to 3, or r minus the closed interval 2 to 3. So I have launched the multiple choice type poll for this one. Take some time to answer. Let us now discuss the solution. So we have fx and gx given to us. So fx over gx is x squared plus 1 over x squared minus 3x plus 2. Now let us look at the roots of gx function. So it's a quadratic function, so the roots will occur at negative b, which is plus 3, plus minus b squared, which is 9, minus 4ac, a is 1, c is 2, 4 into 2, 8, by 2a, a is 1. So this gives me 3 plus minus 1 over 2, which is 2 or 1. So that means the denominator can be factorized as follows: x minus 2 times x minus 1. Now square root of f by g, this function is square root of x squared plus 1 over x minus 2 x minus 1, and clearly this is not defined at x equals to 1 and 2, and it is defined everywhere else. So it's a ratio of two polynomials, and these polynomials are not defined exactly at these 2 points, and everywhere else it is defined. So everywhere else it is well defined and therefore differentiable also, because each of these are like polynomials or quadratics to be specific. And quadratic functions and ratios of quadratic functions are well defined and differentiable, except at the point where the roots occur. So the correct option is option number B. It is well defined and differentiable on the entire range of real numbers except at the point 1, 2. So this slash symbol, this backslash is denotes negative sign, meaning real numbers minus the set of 1, 2. Okay, so that solves question number 3. Are there any questions? Okay, seems like it is all fine up until now. So we can proceed further. Question number 4. State whether true or false. For every a, b belonging to the set of real numbers, there exists a c belonging to real numbers such that the function fx equals x squared minus a over x squared minus b is not differentiable at x equals c. Now this is once again a true false type question, so I will start the true false type poll. let us now discuss the solution. So what we have is, we are given the function fx equals x squared minus a over x squared minus b. Now we know that if, let us look at the different conditions. If a equals b, then in that case fx is equal to 1, and this is clearly differentiable at all points. If a is not equal to b, then we know that fx is not defined at x equals root b, provided b is greater than or equal to 0. If b is less than 0, then this is not valid. Then fx is indeed defined even at is indeed defined at all points. Square root for negative numbers is not real number, and we are looking at real numbers. If b is less than 0, then that's what this is the condition. If then fx is defined everywhere. Again, why? Because we are looking at the case for real numbers. We are not considering complex or imaginary numbers. Now, if x is equal to root b, which is basically from here we can see this condition, then fx is not differentiable at x equals c. Why? Because it is not even defined at that point. So function not being defined is definitely not differentiable. So indeed there exists this particular c which is equal to root b, such that this function is not differentiable at that point. So the correct option is true. And the value for the c is square root of b. Again, this is only when b is greater than equal to 0. Moving on to the next question, question number 5. If a function f is differentiable on R, the set of real numbers, is the function root f also differentiable on R? So this is a yes no type question. I will relaunch the poll for yes no type this time. Take a few minutes to answer the question and then we will proceed. Okay, let us now discuss the solution. So what we are given is that let's say this is a function, and if it is differentiable, then you have the derivative denoted as follows: f prime. Then root of f, the derivative of that is going to be 1 over 2 f to the power minus 1 by 2, which is 1 over 2 root f, and this will be not defined for f equals 0. Whenever f is equal to 0, so the function is differentiable, so the function is defined whenever f is 0, but square root of f, the derivative of that, will not be defined. So the correct option for this is no. Now we can move to the next question. It is a similar type of a question. This time instead of square root we have cube root. Okay, another thing in the previous question is that the square root itself is not defined for values of the function less than 0. Whenever the function takes a value which is negative, square root of f is not defined, because we are looking at the set of real numbers. So we are not considering imaginary or complex numbers. So square root itself is not defined. So the next question, question number 6, is similar. If a function f is differentiable on R, is the function cube root of f differentiable or not? Once again, I will restart the yes no type poll. Take some time to answer. Okay, now let us look at the solution. So with cube root, this problem is not there of the function itself not being defined for negative values, because cube root of negative numbers is also defined. The cube of a negative number will be a negative number. So for cube root, the function being negative is not a problem. However, if we look at the derivative, so f, the derivative is f prime, cube root of f, the derivative will be 1 by 3 f of 1 by 3 minus 1 to the power 1 by 3 minus 1. So this is 1 over 3 f to the power minus 2 by 3. Now this also faces the same a similar problem as above, that this is not defined for f equals to whenever f takes the value 0. As a result, even this function is not differentiable. Next question. If a function f is differentiable on R and g is a function such that f of g is differentiable on R, is g differentiable on R or not? We need to see. So once again, I will start the yes no poll.
गैस से जो लेफ्ट साइड में जो कवर है जिसमें राशन रखते हैं, सामने में पॉलिथीन दिख जाएगा, डब्बा टुकड़ा पॉलिथीन में आटा के उनको तेल का बोतल दिखेगा, रिफाइंड का बोतल, उसको पॉलिथीन को पूरा ऊपर रखेगा, उसमें चीनी भी है, नमक भी है। हाँ।
Okay, so let us now look at the solution. FOG, sorry, this is composition of functions. So what this means is you first apply the function g on x and then you apply the function f on this g of x, on this output of g of x. So first you apply the function g and then you apply the function f. That is the meaning of FOG. Now, in order to see this, let us look at some examples. So we have one example, let us take, of g going from R to R to R, such that g of x is equal to x squared, let us say, and then let us take a function f also going from R to R, and let us say that f of x is equal to x plus 1. Now if you see what is the combination, so composition of the function FOG of x is going to be, so first you apply g of x, so that gives you f of g of x is x squared, and now f will be, just you add 1 to that number, so this is going to be x squared plus 1. So this is an example of composition of functions I was trying to show. Now let us come to this question and see whether the statement is true or not. So let me just repeat the question once. So if a function f is differentiable and g is a function such that FOG is also differentiable, then we need to see whether g is differentiable or not. So in this case, then let us look at the following example. So let us say g of x is equal to mod of x and f of x is equal to x squared. In this case, FOG of x is going to be mod of x whole squared, which is the same thing as x squared. And why so? Because, well, mod of x is a function defined piecewise as follows. And here now if you take squared, and negative x squared is same thing as x squared, so this whole thing just simply becomes x squared. Now in this example we see that f is differentiable because x squared is differentiable. We see that FOG is x squared, which is also differentiable. F and FOG, they are both same over here. However, g, which is mod of x, is not differentiable. And we saw that earlier in the first question. We saw this plot and we saw that mod of x is not a differentiable function. Because at x equal to 0 it is not differentiable. So clearly we have that f and FOG are differentiable, but g is not differentiable. So is g differentiable? From one example we saw that no, g is not differentiable. So to disprove something, it is enough to show one example, but in order to prove a statement you need to be general. But here we just have to see show whether g is differentiable or not, and just with one example we can claim that, well, g is not differentiable. At least in this case it is not differentiable. So even in the most general case it will not be differentiable, because there is at least one example which says that it is not differentiable. Okay, so now we can proceed further to the next question. Question number 8. If a function f is differentiable on R and g is a function such that g of is differentiable on R, is g differentiable on R or not? It's a similar kind of a question. This time the composition order is different. Instead of f o g, we have g o f. So first we apply the function f and then we apply the function g. So once again I will start the yes no poll. All of you please try to attempt the poll. It's always a good practice to first try solving the question and then look at the solution. So take a few minutes to solve the question and then we will discuss the solution. Okay, let us now discuss the solution. It's a similar kind of a problem, so we will begin with a similar example. So once again we will say, let's say f of x equals x squared and g of x is mod of x. So g o f of x will be mod of x squared, because fx is x squared and then you apply g, which is to take mod. Now x squared itself is positive, so mod of x squared will simply be x squared, and clearly we see that f is differentiable because x squared is differentiable. G o f is also differentiable because that is also x squared. But once again g is not differentiable because it is mod x, and mod x we saw in the first question, it's not a differentiable function because it is not differentiable at x equal to 0. So once again the correct option is no, just like in the previous case. So we can proceed further. Now we have a few descriptive questions. So these are not multiple choice type questions or true false or yes no type questions. These are actually descriptive questions. So we need to solve these. These are word problems. We need to formulate it into a mathematical form. Question number 9. Suppose that an individual's post-tax income y is related to his pre-tax income x as follows: y equals 100 plus 4 by 5x. Then we need to find out these three things. Part 1, find the relation between his tax t and his pre-tax income x. Part 2, find the marginal tax rate, and part 3, find the average tax rate of an individual and his pre-tax income x. So take some time to solve this question. There will be no poll for this one because it is a subjective question. Okay, so let us start solving this question. Part 1. So tax is actually x minus y, which is the pre-tax income minus the post-tax income. So that's tax as a function of pre-tax income x. Then part 2, marginal tax rate. That is the derivative of the tax function, which is derivative of this x by 5 minus 100, which is simply 1 over 5. And finally the average tax rate. That's the tax over x, which is the pre-tax income. Now at x equals 1000, this becomes the following. So in percentage, this is 10%. So 10% is the average tax rate. Now the next question, the 10th question. We have a total of 13 questions this time. So after this 10th question, we will take a short break. Let a firm's total cost C be a function of Q, the quantity produced, and it is given by the following expression. CQ, C as a function of Q, is Q cubed minus 4Q squared plus 12Q. And there are two parts to this question. We need to find part 1, the average cost and the marginal cost. And we need to see when the average cost equals the marginal cost. Part 2, here the cost function changes to being Q cubed minus 4Q squared plus 12Q, the same as previous, plus an additional constant of 10. And we need to see what effect this has on the average cost and the marginal cost. So once again, take some time to solve this question and then we will discuss the solution. Okay, so let us now discuss the solution. So average cost is the cost over the quantity produced Q, which is the following. The marginal cost is the derivative of the cost function. Now the condition when the average cost equals marginal cost is the following. We will equate these two expressions. The constant drops off. So this gives the solution as Q equals 0 or 2. Now quantity cannot be 0. So for positive quantity, I mean 0 quantity is like no production. So for positive quantity or at least some production, we have Q equals 2 units. Now part 2, the cost function is changed. As a result, the average cost now becomes the following. And the marginal cost remains the same because the derivative of a constant is 0. So this remains the same as previous. Okay, so now let us take a short break of 5 minutes before we move on to the next few questions. Okay, so let us now proceed. I hope everyone is back. This is becoming a slightly longer session. Question number 11. The demand function of a certain product is such. Okay, just give me a second. So let us just read the question again. So question number 11. The demand function of a certain product is such that the total amount received in sales is always the same, regardless of the quantity sold. Write the functional relation between the demand and the price and calculate the elasticity of demand.
स्टार मतलब नहीं बात है रियली गुड मतलब एक्सेप्शनली गुड 3 स्टार टीनेजर वाला क्या टी हाँ TEENS 3 स्टार बहुत ही मतलब कितना बात में रहा इतना अच्छा नहीं पता मैं तो पुराने वो जाके ही इतना नमस्कार करेंगे फिर क्या से कपड़े दिखाएगा मतलब सबके साइज भी उसको पता हो जाता है हम ही आप रेडी के लिए रहने बैठे हैं या फिर मतलब चेंज करने जाता है कि बहुत अच्छा होता है
Okay, so let us now look at the solution. So total amount received so let the total amount received be A, which is positive, and demand is Q, price is P. So total amount received A will be price for one quantity times the demand quantity, which is P times Q. So this gives me Q equals A over P. So dQ over dP is minus A over P squared. So elasticity of demand is dQ over dP times P over Q, which is negative A over P squared. This is dQ by dP times P over Q. Q is A over P. So A cancels out. This P along with this P becomes P squared, and so P squared also cancels out, giving us negative 1. So that's the elasticity of demand. So it is unit elastic. Next question, question number 12. Find the income elasticity of Q for the following functions relating demand Q to income Y. So we have the two parts actually. First one, the Q is given as AY plus B, and second one is Q is given as AY to the power B. And now we need to analyze the behavior of elasticity as the income changes. So once again, take some time to solve the question and then we will discuss.
बॉम्बे डायरी के सामने बस हाँ बिल्कुल सामने बॉम्बे डायरी की दुकान है तो ज़्यादा वाले है ना बॉम्बे डायरी के सामने आपको अगर सिंपल कपड़े ले रहे हैं अच्छे सोबर वाले हाँ सारे सिंपल है वेरी रीजनेबल और कपड़े बहुत चलते हैं सालों साल खराब नहीं बाकी खराब
Okay, so let us now look at the solution. So we define the elasticity of demand, how it is written over here. It is dq over dp times p over q. So for the first example in this question, the elasticity of demand dq over dy, because here now this variable is y, times y over q. So dq over dy, that's a, times y over q, and q is ay plus b, and this is clearly positive, and limit y tending to infinity is plus 1. For the next part, so dq over dy now will be a b y to the power b minus 1. So a cancels out, and y to the power b minus 1 times y, that's y to the power b, so this also cancels out. This gives us b, and this is a constant and does not vary with the income. So income can keep changing, but elasticity of demand in this case remains constant. Finally, the last question for the day. Let the demand Q and price P be related as P equals 60 minus 0.5 Q. The three parts are: express epsilon D, which is the elasticity of demand, purely in terms of P and then in terms of Q. Calculate epsilon D when Q equals 100, and calculate the demand when epsilon D equals negative 1.5. So take some time to solve the question and then we will discuss. This is the last question for today. Okay, so let us now discuss the solution. So we are given that P equals 60 minus 0.5 Q. So rearranging gives us Q equals 60 minus P over 0.5, which is equal to 120 minus 2P. Now in this case, elasticity of demand, so that's going to be dQ over dP times P over Q. So dQ over dP is simply -2, and then P over Q is P over 120 minus 2P. So this is minus 2P over 120 minus 2P, which is -2 times P is 60 minus 0.5 Q, 60 minus 0.5 Q over Q. This is another way of writing. So minus 2P over Q. So this is P and then this is Q. So this becomes minus 120 plus Q over Q. So you can write it like in terms of P or in terms of Q. Now for the next part, epsilon D when Q equals 100 is the following. So minus 120 plus Q over Q when Q equals 100. So that's minus 120 plus 100 over 100, which is minus 0.2. And finally, the last part, we are given that epsilon D equals minus 1.5, which is minus 120 plus Q over Q. So this gives minus 3/2, that's 1.5 times Q equals minus 120 plus Q, which implies 120 equals 5/2 Q. So Q equals 120 into 2, which is 240 divided by 5. So 240 divided by 5, how much is that? So Q is basically 120 into 2 divided by 5. So 5 2s are 10, 2 is remaining, and 5 4s are 20. So this becomes 48. That's the value of Q. Okay, so this brings us to the end of today's session. This was week 6. We will meet next week, next Saturday at 3 p.m. for week 7. So that's all from my end for today. If you have any questions, you can ask right now, or you can ask later on, either on the course forum or on the YouTube chat. Okay, so that's it. Bye bye. See you next time.